Today's sponsor is Datadog. If your business is being driven by software, you know today's applications are more complex than ever. They're sitting on multiple layers of infrastructure and distributed services, and it can be very complicated to manage. Datadog brings visibility into every part of your infrastructure, as well as APM monitoring for your application's performance. Customizable dashboards, collaboration tools, and alerts let you develop your own workflow for observability and incident response. And Datadog integrates seamlessly with all of your apps and systems, from Amazon Web Services to Kubernetes to MySQL, so you can get visibility in minutes. You want to get started now? Go to datadog.com/cloudcast to get started with Datadog and get a free t-shirt.
This week's show is brought to you by Media Temple. Whether you're looking to migrate a business-critical site or application to the cloud, Media Temple is your trusted team. Their experts can help you move to the cloud, maximize application performance, and find peace with your infrastructure once you're there. Visit MediaTemple.net to learn more about all of their managed cloud services and to unlock the full potential of your virtual private cloud or the public cloud.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast, coming to you live from the massive studios here in Raleigh, North Carolina. Folks, you know, it's a real nice and sunny day here. We're getting towards the fall. And before we get into sort of the interesting cloud conversations that we're going to have, we want to talk real quick about some unfortunate cloud situations that hopefully you guys are paying attention to. Obviously, there's a lot of difficult things going on down in Houston and Texas and Louisiana with the whole Hurricane Harvey hurricane and flood and tornadoes and stuff. And so before we get into the show, if you have the opportunity, if you're capable of doing it, help those folks out. We'll put a link to Red Cross. Go to redcross.org. Make a donation. Anything helps. $5, $1, $10, $100. If your company does a matching thing, that's great. Get a matching thing. But those folks are going to have a hard time for, unfortunately, a very long time, and they're going to need all the help they can get, whether it's cash donations, food, water, diapers, everything they're going to need for quite a long time. So if you get a chance, please make a donation. It will significantly help down there, and they will greatly appreciate it. With that, talk about some more cloudy, less dark cloud news. So one of the things that we're very lucky to do is we get a chance to partner with O'Reilly Media, especially when they have shows and stuff, and they have a lot of really good conferences several times a year. One of the shows that's coming up here in just a few weeks is the Velocity Conference. And Velocity, for anybody who's into DevOps, into SRE, operations, automation, fantastic show. It'll be in New York City. And we're very lucky this week to have one of the speakers that's going to be has been presenting for a lot of the O'Reilly shows as an O'Reilly author, and is heavily involved with the community. So very excited to have Seth Vargo, who is Director of Technical Evangelism for HashiCorp. Seth, welcome to the show.
Thanks, Brian. Thanks for having me.
Thanks for coming on. You know, HashiCorp, we've had a chance to talk to Mitchell and some others from your company for a while. We've talked about things like Vagrant and DevOps. You are heavily involved with a lot of the technologies around secrets management. Give us a little bit of your background, because you've got quite a bit of interesting background around technology as well as being an author. Give us a little bit of a sense of your background before we jump into stuff.
You know, I did my undergrad at Carnegie Mellon. You know, I have all of the degrees and diplomas to kind of back up what I say. But, I worked at a place called Custom Ink for a while. They're an online t-shirt retailer doing operations. I worked at Chef Software, formerly known as Opscode, and the people who make Chef and, Chef provisioning, et cetera, for about 2.5 years. And I'm coming up on my 3 year at HashiCorp in this October. So it's been a pretty exciting journey. And I work on all of the tools. So at HashiCorp, we make a bunch of open source tools: Vagrant Packer, Surf Console, Terraform, Vault, and Nomad. And, today we're going to be talking about Vault, which is the secrets management solution, fully open source, that we have at HashiCorp, and kind of how it can solve organizational secret problems, whether you're, a tiny startup of 2 or 3 people or a big, massive 20, 30,000 person enterprise.
So Vault is, fundamentally, I think we've talked to Kevin, who runs product and so forth. He kind of lumps it in as sort of like an HSM. Obviously, it's a software product, but it fits in that space of helping you manage encryption, helping you manage keys. What other kind of domains does it sort of fit in? Where does somebody wake up in the morning and go, okay, I have this type of problem. Vault is the type of technology that's going to help me solve that?
Yeah, that's a great question, Brian. I think it's helpful to take a step back and, let's travel back in time about 20 or 30 years. When you think of the traditional data center, it was a brick and mortar building. Maybe you owned it, or maybe it was a co-located space. And everything inside of that data center was trusted. You had everything behind a single firewall, and your biggest concern was physical access to that data. What happens if someone comes and pulls the hard drive out of my rack of servers? And there wasn't really communication over the public wire that didn't go through some type of firewall that was controlling all the inbound and outbound traffic. And similarly, applications were very monolithic. You had your Java app or your COBOL app, and everything that application needed was self-contained. So you weren't communicating over the network with other services. Now, if we fast forward to really about 8 to 10 years ago, we start seeing this proliferation and this idea of a service-oriented architecture, where not only are we leveraging cloud technologies, so we might not be in our own data center where we can trust the machines on which the code is executing, but not all of the information is contained on a single application. Resources are shared, and instead of a physical firewall appliance that we can ensure all traffic goes through, we have rules. And I use rules in air quotes here because there is no concept of all my traffic must flow through this particular barrier. And like inside of this service-oriented architecture, we have our microservices that need to communicate with each other. And they flow between these services and potentially through third-party APIs. There's a ton of services out there. Postgres is a service. Things like hosted database services, things like hosted DNS services, where we need to be able to communicate with those APIs. And as such, the security threats in a modern world have changed drastically. Instead of having armed guards at the door of our data center, we have to really think about the way our applications are communicating with each other. The biggest threats are now unauthorized access at the code layer, things like unauthenticated APIs, credentials that last forever so that a hacker can, brute force them or gain access to your application's data, and lack of a break glass procedure in those situations. What do you do in the event of, an Ashley Madison or a LinkedIn style breach where your alerting and your monitoring is telling you, hey, you have a data breach? How quickly can you respond to that while, minimizing customer downtime, but not having to, SSH into 100,000 machines to revoke a credential? So the easiest way to think about Vault is it's really modern secrets management, or secrets as a service. And there are a number of tools out there, some that have existed for a long time and some that are relatively new to the market, that do one piece of what Vault does. And I'll give you a really classic example. One of the questions I get asked a lot is, what's the difference between Vault and Amazon's KMS or Google's Key Store? And the answer is very simple. Vault provides this thing called a transit backend, which provides encryption as a service. And it's almost exactly the same as Amazon KMS or Google Key Storage, where you ask the clouds to encrypt some data for you and they manage the encryption key all through an API. But the transit backend is just one of 8 backends built into Vault, and Vault has a plugin architecture, so it can be extended even further. And for this reason, it's sometimes hard to talk about Vault because it solves so many different use cases. And again, it depends on the needs of your organization and how your organization is structured on how you might use some of these features.
One of the things that Aaron, Delp, and I have always sort of said about the HashiCorp products, the projects that you guys have built and the products and so forth is, they always have a really strong operational, I don't want to say bias, that's the wrong word, but they're always built from the perspective of like, if we were using these ourselves, what would we build into them? And I think we've always been, really positive about what they've done, because a lot of times products get built that sort of fit a category. They fit and they're trying to look like something that the competition makes, or they're going to fit into a certain category that an analyst has. And we've always sort of commented that the HashiCorp products are always like, no, they go that next extra step, which is the thing that operations wish they had built in, or it had some flexibility they had built in. So yeah, highlighting that I think is really important. Your talk at Velocity is about microservices, giving that historical context. You talked about SOA, and people will say, well, microservices is kind of a next generation of SOA, but really it's highlighting you've got distributed types of systems, distributed places where traffic comes in and out, distributed places where data is stored. Why are we seeing so much more conversation about secrets and secrets management now in the microservices space? Is Is it because things are changing more frequently and the secrets are changing more frequently, or is there just kind of a fundamental connection between microservices and secret management?
I think there's a few reasons, but I do want to backtrack real quick on something you said earlier about how HashiCorp kind of solves the right problems. Just a real quick, 1 minute story. Vault was never going to be an open source project. We built what was not called Vault at the time because we offer a hosted service in which you have to give us cloud credentials, and we needed to be able to prove deterministically that they were not at risk. So we built this tool that solved our problem, and then we had some conversations internally, and I had suggested, hey, this should just be an open source tool. We should rebrand it and make it something. And that's part of the reason why a lot of people love our tools is that we use them internally. We provision our own infrastructure with Terraform. We secure our own data with Vault. We do our development environments with Vagrant. I think it's something unique about our company, which is we really take dogfooding seriously, and we use all these tools internally. But back to your question about why is this becoming so important? I think there's three main reasons. The first is we started recently to see a massive uptick in data breaches. I forget the statistic off the top of my head, but there's almost 100 times more data breaches in the first quarter of this year than there were in the past 20 years combined. It's super exponential. A lot of that is because we have to rethink the way that we secure our data. And a lot of these big enterprise organizations that have been around for a very long time, the credit card processors, the big banks, they're performing this cloud migration because they want to leverage the elasticity of the public cloud. And the challenge is that a lot of them are just lift and shift. They're taking their existing VMware applications and putting them on, Amazon's hypervisor or Google or Azure's hypervisor. While that works and the application still functions, we have to think about security holistically. No longer are those applications behind a firewall. They're behind a security group, but those rules might be different, and we have to rethink how accessible that data is. I think that's the first thing is we see data moving and applications moving from a physical data center that's well guarded and understood to public cloud environments that are slightly less understood. And I'm not saying that the public cloud is less secure by any means. I'm saying that it's different security. We have to think about things differently. I think the second reason we're starting to see this is just the number of services. In a traditional, monolithic application, you have the banking application, and it does everything. And it gets deployed once a quarter, once a half, once a year, and everything is self-contained. There's no external communication. So we don't have to worry about things like man-in-the-middle attacks or, what happens in the event when someone sends too big of a TCP packet to something to overload it. Because everything's self-contained. We're not communicating across services. But more recently, we realized that in order to scale our services horizontally and vertically, we need to break them apart. Because some services need to run 100 instances and other services might get away with 2 or 3. But then we have to think about the communication between those services, which is, okay, now I have these 2 services. How can I guarantee they can talk to each other? If service A sends a message to service B, how does it guarantee that not only is service A the right service A, but service B is the right service B? If someone else is sitting in on that network, how can they make sure that those requests are authenticated from both the client side and the server side? And this is where we start talking about things like TLS and mutual TLS, which is the client-side validation of TLS. And then the third piece is a little bit different, which is the human component. Everything, point 1 and point 2 are very technical, but point 3 is the human component. As we see tools like Kubernetes and Nomad and Mesos and Mesosphere kind of explode, Pivotal, Cloud Foundry, et cetera, the traditional way that we as operators debug applications changes. If you talk to anyone who's worked in the ops space for a while, they'll probably tell you their favorite tool is, tail-f and cat.
Right.
And when you start moving into these scheduled architectures, these cloud architectures where you have, 500 instances of an application running across all 3 major clouds, you can't tail-f the cloud. And oftentimes we see shortcuts to enable that level of behavior where, we're aggregating logging data in an insecure way so that we can use those familiar tools, but we don't add security around it. And I always just like to pose the question to any of the listeners and promise that this question will last for 20 years. How many of you have a production credential on your laptop or Surface or whatever right now? And your first answer is probably no, I don't have any of that. And then I like to pose the second question, which is, can you push or pull production code from your current device? Do you have access to GitHub? Do you have access to GitLab or Bitbucket or some type of internal code store? And if the answer to that is yes, you have access to production data. And if someone gains access to your laptop, they could produce malicious code into the environment. And if you left the company today, how many people know that you have that production credential on your laptop, and how quickly could they be able to revoke it? Because sometimes employees leave on good terms, and sometimes they leave on not so good terms. And in those situations, we need to be able to revoke access to anything that employee previously created or continues to have access to. And this is something that is often an oversight. It's a wiki or a playbook that an ops team or an IT team has to go through and check off some boxes. And we know that humans are really bad at repetitive tasks, but computers are really good at it. And that's one of the reasons why Vault is so successful, is it not only manages, the security of the applications and the communication between the applications, but it also has a human element to it as well. You can think of Vault as encoding or codifying all of the policies and procedures you have around, onboarding employees, removing employees, promoting, depromotion, but it's all codified. It's not a wiki. It's not, a page on some internal site. It's in code, which means it's going to be executed identically every single time.
No, it makes a ton of sense. I sort of asked this question. It's one of these ones where I think the answer is probably all of them. But I mean, do you see, as you're working with different organizations or you're talking with security teams, is there one area that they find is more critical, or they're spending more time on? Is it key rotation? Is it encryption strength? Is it auditing capabilities? I mean, obviously all of them sort of have to be there, but in today's world, are any of those things or any element of what Vault delivers kind of more important than others?
I think it depends on the size of the organization. In some of the big financial institutions, it's definitely more focused on the compliance and auditing side of things. Vault enables you to come in and check so many checkboxes off of the auditing and compliance report. You can definitively say we have no credential that lasts longer than 30 minutes. You can definitively say that we've rotated every key in our infrastructure in the past 30 days. It lets you check off those boxes. And if anyone's ever seen some of those compliance forms, they're hundreds of pages of checkboxes. And alleviating any amount of that pain is something that security professionals love to do. I think in medium and smaller organizations, it's this dynamic credential process that really gets people excited about Vault. They're less concerned about key rotation and like the durability and high availability and those types of things, and more concerned with, I want every instance of my application to have a unique database credential. So instead of having a DBA or someone, manually create a Postgres username and login, then copy and paste it into a text file, they want each of these applications at boot to talk to Vault and get a database credential. And Vault will programmatically generate those database credentials for you on the fly. What does that actually buy you, though? Well, the answer there is that if an application host has unauthorized access, someone SSHs into it, we have anomaly detection that indicates it has a problem, we can revoke that one database credential and not touch the rest of the fleet. This is what we call the break glass procedure in Vault, which is if you think you've been breached, how do you recover from that breach while minimizing the downtime, right? You could take your whole app offline, but that's going to impact your users and your customers. So by having each application have its own database credential, we create this thing called provenance, which is a one-to-one mapping of the application to its credentials. And this is very important as you start scaling out, because you want to be able to map things back to audit logs and anomaly detection software and application logs to see where there might be some funky things going on. And then on the flip side of that, again, there's the human element. Let's say your application developers need access to AWS, and they need an API key in order to maybe deploy some stuff in a staging environment or their development environment. It takes over 10 clicks to create an IAM credential via the web UI, and you can do it via the CLI, but then the person who created those credentials sees them, and then they email them or give them to the coworker, and now two people have the same credentials. We don't have provenance anymore. With Vault, one of those employees can authenticate to Vault using something like a username and password, Active Directory integration, or even log in with GitHub, and then request their own AWS credentials. Vault will programmatically generate them and return them just to that user. So when we're looking in the CloudWatch logs, for example, and we see, oh, this particular access key is performing malicious behavior, we know exactly who is doing that. we don't narrow it down to 2 people, we narrow it down to 1 person because that's the only person who had access to that key. And those keys have a lifetime, just like the database credentials. So instead of a key that lives until someone goes and deletes it, Vault can enforce what we call a lease. And it's very similar to like a DHCP or DNS lease. When you get a credential in Vault, that credential does not live forever. It has a lifetime. And that lifetime is configurable. It might be 30 minutes, it might be 30 days. But at the end of that lifetime, Vault will revoke that secret. And this helps prevent secret sprawl and the proliferation of all of these unused secrets, which ultimately decreases the surface area for an attack.
It makes sense. And again, it goes back to that whole premise of think about what real sort of problems people have. I mean, being able to do, user level isolation of that, user level isolation of just not just the credential, but sort of the process of how they get that. I mean, it allows you to not only have employees, contractors, contractors out of the country that might be sort of a second or third party contractor. I mean, that level of granularity becomes really, really important in terms of, like you said, not only how you distribute credentials, give out keys, but also how you revoke them. Given, I think you've done a really nice job of establishing kind of the criticality of, secrets management, encryption management in these new environments because of lots of inputs, lots of outputs. The doors aren't where the doors used to be, type of thing. How do we make sure that that key management system, Vault, stays highly available? I mean, if I lose that thing, now all of a sudden my applications can't talk to each other. I can't log into stuff. How do you ensure that it's highly available? How do you deal with, sort of disasters and stuff like that?
Yeah, that's a great question. One thing to clarify is that Vault is not a proxy. This is a really common misconception. When you want to talk to a database, your application requests a credential from Vault. Vault goes out, talks to the database, generates the credential, and returns it back to the application. From that point, Vault's work is done. The application communicates directly with the database. So Vault isn't a proxy. Not every request and response goes through Vault. It's only the generation and the renewal of secrets that goes through Vault. So it's not something that is, sitting in the middle of every request. Gotcha. But there's still obviously a desire for high availability. And in that mode, Vault has a number of different what we call backends or storage backends for high availability. Vault is architected in a way where it has a client server model. It's an HTTPS server, and then it stores data in a backend. And you can think of a backend, the easiest one to think of is the file system. Whenever data comes into Vault, Vault is going to encrypt that data and then persist it encrypted on the file system. Now, those backends are pluggable. So, for example, you could store that data in something like Consul, which is one of our open source service discovery tools. You could store it in something like etcd, which is the tool that backs Kubernetes storage. There's a number of configurable storage backends out there. Vault itself operates in a highly available manner based off of the storage backend. So if you're using a storage backend that is highly available, Vault will be highly available. You could run 3 instances, 10 instances, 1 million instances if you wanted to, but they're all going to delegate to the same shared storage backend. Now, in the case of the file system, the file system is not highly available, so you can't utilize that for a highly available Vault installation. You'd have to use something like Consul, which is highly available and supports locking, in order to reach high availability mode.
Gotcha. No, makes sense. And obviously, I think that's one of the things that well documented. Folks can go take a look at it. Probably not something you're going to pick up completely in 5 minutes on the podcast without a whiteboard and lots of docs. One of the things that obviously happens whenever we talk about microservices is the conversation eventually moves to, great, you built this application, let's deploy it into production. And the conversation of container schedulers comes up, whether it's Kubernetes or Mesos or OpenShift or Cloud Foundry or whatever it is out there, ECS from AWS. What do people have to kind of be aware of in terms of secrets management in the context of schedulers and orchestrators and so forth?
Yeah, that's a great question. When we think about the move, and this kind of goes back to our conversation about lift and shift before, when we start deploying applications into a container scheduler or a scheduled environment, a lot of our previous assumptions get voided. Like a really good example is in like a traditional physical data center, we hard code IP addresses because we know that's where they're going to be. And when we move to the cloud, we can still get away with that a little bit, But when we move to a container scheduler, such as like Nomad or Kubernetes, it's impossible. The container scheduler is going to put our application wherever it wants to. And in the event that a host dies or the cluster capacity changes, the scheduler can move that application at any given time. And that's something we have to be able to account for. So totally out of the realm of Vault is that your applications need to be what I like to call cloud native. They need to have a way to gracefully start and stop. They need to be able to drain their HTTP connections if they're a server, or drain their RPC connections. They need a way to be graceful in this environment. They need to respond well to being able to be moved around. I like to always draw the analogy, which is the traditional brick and mortar data center was very similar to humans. You couldn't pick up a human and move them to a new house without a lot of stress, right? There was a lot of moving of things. And when we move to a container architecture, things are a little bit more nomadic. You just pick everything up and go. And you need to be able to do that very quickly and very responsively. When it comes to credentials, when we introduce Vault into the story, then the same principles apply, but they're extended even further, which is whenever that application is scheduled, we want to give that application or that container all of the things it needs to communicate at boot time. So instead of the application being responsible for communicating with Vault, getting its credential to talk to the database, getting its credential to communicate via TLS, or doing some type of encryption as a service, we rely on the scheduler to do that. So, and this is where at HashiCorp we have open source the Vault Service Broker, which is part of the Open Service Broker API. It integrates with OpenShift, Kubernetes, and Cloud Foundry, which you run as a service inside your cluster, like as a system service inside your cluster. And whenever applications are scheduled, they bind to that service, and that service handles the complexity of interacting with Vault and getting all of the environment variables and the secrets that particular application needs. And that's all configured, in advance based off of the app name or the app ID or something like that. Now, in the event of Nomad, which is our open source application scheduler, we have a bit deeper integrations. And that's not because we're biased. It's just because we control both of those tools.
Yeah, makes sense.
So we can build really deep integrations. And this is all very heavily documented. But when you integrate Vault and Nomad, you can get job specific permissions. So in Nomad, a job is kind of similar to like a Kubernetes pod, to draw an analogy. And when Nomad and Vault are interacting together, you can use Vault not only as the authentication for the application layer, which is, can this app get these database secrets? Can this app encrypt this data? But you can use it for the human layer as well. Is the person who is submitting this job allowed to submit this job? Are they allowed to submit this many copies of the job, et cetera? So it's both a human authenticator and an application layer authenticator.
Well, listen, we have covered a ton of stuff just in a short period of time, and want to thank you for the time today. Let me ask you one last question. I've had a chance to get out to Pittsburgh a couple of times this year. You went to school there, you lived there. Give folks just 2 minutes real quick, like, how has Pittsburgh evolved back into becoming kind of a really first-class tech city? Like, what's going on there? What are some of the cool projects going on? What's the culture around Pittsburgh?
Yeah, it's a great question. I moved here in 2009, and it's changed so drastically. I think there's a few big key players. Google Pittsburgh is a huge office. It's actually where most of the site reliability engineers live, especially for ads, which is, as you know, where Google makes all their money.
Yep.
Apple has a big presence here, and more recently, in the past 5 to 10 years, Uber has made a big presence here. The Advanced Technologies Group, which is the self-driving car division of Uber, is headquartered here in Pittsburgh. They employ thousands of people on the self-driving cars, and if you ever visit Pittsburgh, especially recently around the Shadyside area, it's almost futuristic. You see these like spaceship-looking cars driving around with rotating lasers on top, and they're driverless. They're driving people around via computers. I think Carnegie Mellon and Pitt and Duquesne and Chatham, the universities in the area, finally got around to curating a startup culture and getting people to stay in the area. So we're starting to see a big increase in population, a big increase in technology. And then another big key player is in the past 2 years, we had a bunch of meetups, the Ruby meetup, the Node.js meetup, the Python meetup, and it was hard. And we had a bunch of conferences. We ran DevOps Days Pittsburgh and Steel City Ruby. And one of the organizers there, Justin Reese, decided to form like a co-op or coalition called Code and Supply. And Code and Supply is a nonprofit organization that runs basically all of the conferences and all of the meetups in Pittsburgh now. So everything's unified. It has a single budget, and it kind of falls under this umbrella org, which helps get cross-pollination as well, right? People who used to attend just the Python meetup are now going to the Go meetup and vice versa. So a lot of really good idea sharing and a lot of really cool industry up and coming. Oh, we also have Duolingo. I can see Duolingo outside of my window. So if you have that app installed on your phone, they're also headquartered here in Pittsburgh.
Yeah, very cool. It's like I said, I've been there a couple of times. One of the times my Uber from the airport was one of those self-driving cars. They were still doing some beta testing, so there was a driver in the passenger seat. But that's a little freaky, especially at night when there's nobody behind the wheel. But great food. If you're into sports, the stadiums are fantastic. They're all down on the river. Really good architecture. So if you get a chance, go out to Pittsburgh. Pittsburgh is a very, very cool city. It's nice people. The weather, you get all four seasons. So definitely a plug for Pittsburgh. Seth, thanks so much for being on the show today. Folks, like we said, Seth is going to be speaking at Velocity in New York City here in just a few weeks, along with a ton of other very, very smart folks, a lot of interesting topics. We will have a link in the show notes if you want a discount code to go to the show if you're in and around New York City. So for Aaron and for Seth, thanks again for being on the show, folks. Thank you for listening, and we will talk to you next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.